Okay, so in this video, we will solve problem 9D from problem sheet number 7. So if you recall the setup, there are in total 15 cars, 3 of which contain counterfeit cigarettes. And the remaining 12, as there are 15 cars in total, so the remaining 12 do not. And a customs officer inspects out of these 15 cars randomly 4 cars. So he or she randomly selects 4 cars out of the 15 for inspection. So 4 cars are randomly inspected. So the selection of which 4 cars out of the 15 cars are inspected is done randomly. Let us make one more definition. So we will let the number symbol C equal the number of cars with cigarettes out of the 4 inspected ones. And the question in D is to find the probability that out of the 4 selected cars for inspection, at least 2 contain counterfeit cigarettes. So we want the number of cars that contain counterfeit cigarettes out of the 4 cars selected for inspection to be at least 2. So we can write this very concisely like this. Well, what are the possible values for this quantity? Out of the 4 selected cars, how many containing counterfeit cigarettes? Well, at first you might think, well, either none, 1, 2, 3, or 4, since we're selecting up to, well, exactly 4 cars, and up to 4 may contain cigarettes, but that's not the case because in total, out of the 15 available cars, only 3 contain cigarettes. So there cannot be 4 cars that contain counterfeit cigarettes out of the 4 that we've inspected, as there are at most 3. So we can separate this into 2 separate events. Either, if number of cars with cigarettes is at least 2, either that number is 2, or plus that number is 3. Again, as we've said, it cannot be 4. There are not enough cars with cigarettes. So this is our event. Either C is 2 or C is 3. And so you see here there is no need to use the complement rule and doing 1 minus the probability that C is 0 or 1, as the event itself is no more simple or complex than its complement. So the complement rule here is not useful. We can do this directly. Now what is the setup, right? Each car, since it is selected randomly, has the same probability of being selected. So we can use here the law of equiprobability, telling us that probabilities are simple fractions. Now, once a car is selected for inspection, and we select the next car for inspection, the first car is not put back in the lot and can be chosen again, right? Once you've selected a car for inspection, that one is out of the other possible cars chosen for inspection. So we have clearly here a selection that is without replacement. And nowhere in here do we say that we care about which car was selected first and inspected first, second, third, and so on. So we also don't care about the order of the selection. So we have an unordered selection done without replacement. That is the setup for combinations. So let's find the first probability. So that 2 of the 4 selected cars contain cigarettes. So again, this will be a fraction out of the total number of possibilities. That is, of course, out of the 15 available cars, we choose 4. And out of those many possibilities, how many will be a selection of 4 cars with exactly 2 cars having cigarettes? Well, this means out of the 3 cars that contain cigarettes, exactly 2 are chosen. So out of the 3, we choose 2. And this is not all, right? We are choosing 4 cars in total. So out of the 3 that contain cigarettes, we choose 2. And times, therefore, out of the 12 that do not contain cigarettes, we choose the remaining 2. Again, because in total, we have to choose 4 cars. 2 that contain cigarettes out of the possible 3. 2 that do not contain cigarettes out of the possible 12. Or, plus, same thing, when the number of cars with cigarettes being 3, the total hasn't changed, right? There are still 15 cars in total, choosing 4. Total number of possible selection of 4 cars out of the 15 available. But now 3 cars contain cigarettes. So out of the 3 that do, we choose all 3. This is, of course, 1, but for good measure, we write it down. And again, that's not all. We are choosing 4 cars in total. We're missing 1. So 3 from the cars that contain cigarettes, and out of the 12 that do not, we choose the remaining 1 car. 12 choose 1. If you use your calculator, so the numerator will be 198 for the first fraction over 1,365 plus, of course, same denominator for the second fraction. And the numerator, again, if you use your calculator, is simply 12. And this was obvious, right? 3 choose 3 is 1. 12 choose 1 is 12. So 12 times 1, 12. This is an obvious, or I should say trivial addition. 198 plus 2 is 200 plus 1, 210. So out of a total number of possible ways of choosing 4 cars out of 15, so that's 1,365 different possible 4-car selection, 210 will be such that at least 2 of the cars out of the 4 contain cigarettes. And to get a more intuitive feel for this, we can use our calculator to get a decimal answer. So the approximation is about, if we round off to the 3rd decimal place, 0.154. So about 15%. So if we summarize, there are 15 cars in total, 3 of which contain cigarettes. Out of those 15, 4 are randomly selected, then inspected for cigarettes, and the probability that out of the 4 cars chosen, selected for inspection, at least 2 of them contain counterfeit cigarettes is about 15%.